A very good evening, everyone. Welcome to the India's most comprehensive live learning platform, that is BYJU'S Exam Prep, everyone. And today's session is going to be a very important session for all of you. Because in the today's session, we are going to be discussing superelevation, one of the most important topics from the transportation engineering subject. So quickly join everyone, and in the today's session we are going to get an in-depth knowledge and all the different types of problems which are asked in the superelevation topic, because this topic fetches a lot of marks in the GATE examination and you will find a variety of questions which are asked. In the today's session, I will clarify each and every concept in regards to superelevation in detail. Join quickly everyone, we are about to start, and this is a very important session. Once again I will tell you. So let us start with the session, everyone. So quickly comment in the chat section and let me know if the audio and video is clear to all. Okay, so we are going to quickly start with the session. Before starting, guys, do not forget to click on the subscribe button so that you get the notification to all such important sessions which we conduct at the BYJU'S Exam Prep platform. Click on the like button and click on the bell icon as well so that you get the notification also. Okay, and do share the session, because it is going to be a very important session and it is also going to help your friends also who are starting your preparation. This session is going to help you kick-start your preparation for GATE 2023. Okay, so this, if you are attending the today's session, that means you have covered a very big topic, a very important topic for the GATE preparation. So it is going to be a very important session. Once again I will tell you, try to make notes after the session. I have taken one session yesterday also on side distance, so try to make the notes for that session also. I am going to bring numericals for the yesterday session as well as for the today session. I will tell you the schedule over there. You will get to know when I am going to discuss numericals. Okay. Okay, everyone. So let me introduce myself. Alright, so guys, my name is Rohan Goyal and I am a master's degree in structural engineering from IIC Bangalore. I have all India rank of 96 in GATE 2020, and these are the subjects that I teach at BYJU'S Exam Prep, and other than these subjects also I take. So you can join my Telegram channel. On this Telegram channel I will provide you the PDF to the today's session. Okay, and I am also going to be providing you an assignment regarding to this series. Assignment is also going to be provided to you on my Telegram channel so that you can practice more. And one very important update that I have on my Telegram channel is I can also conduct a Zoom session for you guys. If you ask me, if you have any doubt, okay, which you want to get clarified from me, talking to me face to face, as we can see that it is a very big gap that we find on the online platform, that students do not get to interact with the faculties, right? So I will also be conducting Zoom sessions over here. So you just have to tell me in the Telegram channel, you just have to comment me in the Zoom doubt. You have to just comment this. Okay, so I will register your name and I will assign a Zoom session, okay, in which we can take your doubts. Okay, we are going to cover all the subjects. Okay, a very good evening, Krishna Algani. Okay, I'm going to take all the subjects on civil engineering. Okay, so we are going to cover all the subjects on the BYJU'S Exam Prep channel. Okay, do just keep subscribing to the channel. Okay, and you are going to be notified to all the sessions which we are going to have. And we are also having one seminar on how to ace GATE 2023 in first attempt by Ashutosh Saxena sir. So a very good insight is going to be given to you on 8th of May at 12:30 PM. You just have to register for this. Okay, you are also going to be provided with a link. okay, in the description, okay, and I will also provide the link to my Telegram channel also in the description. Okay, you can see the chat box. I will provide you the Telegram channel over there. So you can also use that link to join my Telegram channel. I have just shared the Telegram channel link. You will find it in the live chat section. Now, before let us see what is the content. Okay, we will not delay the session because we have a lot to discuss. A lot of important things are going to come, and you can see over here what is the content that we are going to discuss in the today's session. So, first of all, I will tell you what are the further sessions planned. Okay, after the today's session, what are the more sessions that are yet to come. Then what is a centrifugal force? Okay, what is the centrifugal? What is the effect of the centrifugal force if there is no superelevation? How do superelevation work? Okay, now what are the different types of problems? First type of problem is you just have to find superelevation. Second is what is equilibrium superelevation. Third type of problem is when a vehicle is in a stop position, okay, what should be the criteria so that the vehicle should not skid. Then how to design for superelevation. Okay, these two problems are different problems. Okay, find superelevation and design for superelevation are different problems. Ruling minimum radius, absolute minimum radius, and minimum radius beyond which no superelevation is required. There is a lot of confusion in all these three. Okay, so I am going to clarify each and every confusion. In the today's session, we are going to get a complete session on superposition, guys. So are you all ready to start with the session, guys? Are you all ready? Yes, scholarship exam is completed. Are you all ready to start with the session? Are you all ready to know all about the superposition? All right. Let us start. Let us start, everyone. So stay tuned, okay? Keep on listening carefully. Ask me if there is any doubt in the comment section. Okay, just comment it in the comment section and I will refer to your doubt. Okay, whatever your doubt is, you just have to comment. You do not wait for me to ask you. Just comment in the comment section. And meanwhile, I will be explaining. Now, first of all, what are the sessions planned? Okay, so as you know, I have already taken a session on side distance yesterday. So I will be taking superposition today. Tomorrow I will be coming up with a very interesting session on traffic signs. What are all the traffic signs? What are the different categories of traffic sign? Okay, this is a very important information for each and every one of you, and you can share this information to all the family friends also, because traffic sign is one of the most important thing that you should know if you are owning a driving license. So I will be taking a session on this as well. And then we are going to discuss numerical practice session, and I will also be going to be giving you assignment also. A numerical practice session and assignment is also going to be provided in this session. Then we are going to do accidental studies, signal design by Webster's method, and traffic flow studies, that is volume, density and speed relationship is also going to be covered in this series. So all the topics are very important, okay, and are asked in the GATE examination after every few years, right? After from each and every topic you will find questions very frequent enough in the GATE examination. Let us start with the today's session. Okay, first of all, what is the effect of centrifugal force? Now, superelevation is, see, when a vehicle is traveling on a curved path, okay, when a vehicle is traveling on a curved path like this, which is having some radius, right? When a vehicle is traveling on a curved path. Now, when it is traveling on a curved path of some radius r, the centrifugal force will act on the vehicle in the outward direction. Now, if this is the inner edge and if this is the outer edge, so a centrifugal force will act in the outward direction, whose magnitude is mv square by r. Yes or no? mv square by r. So a centrifugal force will act in the outward direction. Let us say this height of the CG is small h. Okay. So P force is acting in the outward direction, whose value is mv square by r. Now the weight of the vehicle will be acting in the downward direction. Okay. The weight of the vehicle will be acting in the downward direction. if this particular distance if this width is, let us call this as B. So this distance will be B by 2. Now, when the centrifugal force is acting like this, now there is a possibility for this vehicle to overturn in this direction, right? When you are running like this in a circular direction, you may fall in the outward direction, right? There is due to the centrifugal force, you may fall in the outward direction. So we have to check whether this vehicle will overturn about this point or not. So in order to check this, in order to avoid overturning, the moment P into H, to avoid overturning, P into H should be less than equal to W into B by 2. Yes or no? So in order to avoid overturning, P by W should be less than equal to B by 2H. In order to avoid overturning. Now, there will be, when this P force is acting like this, now there should be some force which should be giving it the horizontal equilibrium also. What is that force which is providing the horizontal equilibrium? The friction that will be acting. The friction will be providing the horizontal equilibrium. So there will be a frictional force over here. F into normal reaction, that is W. So friction will be acting in the opposite direction, which will be balancing this P load. Now the vehicle may skid if P is greater than this. Now how to avoid skidding? If P is less than or equal to FW. So P by W should be less than equal to F. So in order to avoid skidding, this condition shall be satisfied, and in order to avoid overturning, this condition shall be satisfied. This P by W is also referred to as centrifugal ratio. And it is also referred to as impact factor. Now, what if you want to avoid both skidding as well as overturning? If you want to avoid both skidding as well as overturning, your P by W should be less than or equal to minimum of B by 2H or F. Yes or no? Yes or no? Quickly comment in the chat section and let me know yes or no. Right? How FW? What is friction? Mu into N. Right? Friction is mu into N. Mu is your frictional factor, which I am writing it as F. F is your frictional factor. And W is your normal reaction. So weight W is acting, that means N normal will be there. That from here we get FW. Right? Yes, very good. Very good. So I hope it is clear to all. Okay, so in order to avoid both, your centrifugal ratio should be less than both of these. Now, how to avoid this? Now, pay one attention, guys. Suppose, in order to reduce the centrifugal force, what are the two things that you can do? Either you can reduce the velocity. In order to reduce this P value, either you can reduce the velocity or you can increase the radius. So if you increase the radius of the curve, you can reduce the centrifugal force also. Okay, so keep this in mind. I will use this in the coming slides. Okay, so you can increase the radius to reduce the centrifugal force. Now let us see, what if the speed is too high and you need to require super elevation. So what are you going to do? You are going to increase the outer edge over here. If you see over here, you are having a racing track. So and the outer edge of the road is increased, is at a little height. So now you will provide a super elevation. Now let us see how super elevation is going to help. Now this is your inner edge. Now this is your inner edge and this is your outer edge. And the outer edge is lifted by some amount. Let us say it is provided with a theta slope. Okay. Now let us see how it is helping. So rising the outer edge with respect to the inner edge to counteract the centrifugal force and to reduce the tendency of the vehicle to overturn or skid. Now let us draw the free body diagram, right? F decreases with speed. One second, let me tell you. There is a provision in the IRC, okay, in which it is given, the F values are given. Yes. So F is going to decrease, little bit of difference is there. F is going to little bit decrease with the speed. Okay. Little bit difference is there, yes. Right. But no, the lateral friction as per, that is only for longitudinal friction. F is decreasing with speed as per IRC only for the longitudinal direction. Whereas for the lateral direction, now in this our case, the F is in the lateral direction, right? Because of the vehicle is going to skid in the lateral direction. So for the lateral direction, F is fixed as 0.15. For the lateral direction, okay, F is 0.15. You can write down F is 0.15. F is friction factor in lateral direction, which is equal to 0.15. I have explained this in the previous class. In the yesterday's class, I have explained this. Okay. No, lateral is also given. Okay. All right. Now, if this is inner edge and this is outer edge, let us draw the free body diagram. Now, in our case, in this case, okay, the weight will be acting in the vertically downward direction. The centrifugal force will be acting in the radially outward direction. So, it is going to be acting like this. Okay. Now, let us draw all the components. Okay. Now, let us see. Now, one component will be perpendicular to the road surface like this. So, and this one. Okay. Now we need to check the overturning about this point, right? So we need to check the overturning about this point, or let us see all the components. So if this is theta, see these are two lines and these two lines are perpendicular to these two lines. So when two lines are perpendicular to the previous two lines, the angle made by these two lines is also theta. And this will also, so these are two lines and these are also two lines, same two lines. So this will also be theta. So if this is P, this will be over here P cos theta, and if this is W, this will be W cos theta, and another component of P in this direction will be P sin theta. Okay, another component of W will be in this direction, that is W sin theta, and friction is also going to act in this direction, that is F into N. Now N is equal to, in our case, this normal reaction. So this is your normal reaction. Okay, the normal reaction will be in response to these two things. So it will be equal to P sin theta plus W cos theta. Very simple mechanics, right? So there should be an equilibrium over here. Okay, the forces should be in equilibrium in this direction. So if we apply the force equilibrium in this direction, what the equation you will get? If you apply the force equilibrium in this direction, what is the equation you are going to get? P cos theta minus W sin theta minus Fn should be equal to 0. Substituting all the values, P cos theta minus W sin theta minus F P sin theta plus W cos theta. equal to 0. Separate the P terms, separate the W terms. P cos theta minus F sin theta equal to W sin theta plus cos theta. Okay. Now P by W will come out to be equal to how much? P by W will come out to be equal to sin theta plus cos theta upon sin theta. One second. F will also come right over here. Na? F will also come. Plus F cos theta. Right? Cos theta minus F sin theta. Over here also F cos theta. Over here plus F cos theta minus F sin theta. Take cos theta common from numerator as well as denominator. If you take cos theta common, it will become tan theta plus F divided by 1 minus F tan theta. And this tan theta itself written as E, which is equal to your superelevation. This E value itself is referred to as, this tan theta value itself is referred as superelevation, is equal to E plus F upon 1 minus EF. Now, if you refer to, now this is your formula, this is your initial formula, right? This is your initial formula, all right. Now, if you refer to the maximum superelevations which are recommended for the highway design or the pavement design, let us see this maximum superelevation chart over here. See, for a plain and a rolling terrain, or if it is a hilly terrain which is covered with snow, then a maximum of 7%. That means theta value is 4 degree. If you take tan theta, tan 4 degree, if you calculate, it will almost come out to be equal to 0.07. So a maximum of 7% of superelevation is allowed. If it is a hilly terrain which is not covered with snow, then a maximum of 10%, that is 0.1 value of superelevation is allowed. And if it is in urban areas where there are frequent intersections or where there are few frequent obstructions, okay, over there a maximum of 4% is allowed. So if you look over here, theta value maximum of how much? 7% is there. Okay. Now, if you find this particular value, if you find this particular value EF, so F value is 0.15. So what is 1 minus EF? If we take E value as 0.1, if I take the maximum value of E as 0.1, so 1 minus 0.1 and F value is 0.15. Tell me what is the value you are getting? Tell me what is the value you are getting? You are getting a value of 0.985. Isn't this almost equal to 1? Isn't this almost equal to 1? So that means we can take this almost equal to 1. That means P by W can be considered as E plus F. So writing it, P by W is equal to M V square by R upon, one second. So if P is equal to mv square by R, can I write it like this? P is equal to W by G V square by R. So P by W is equal to V square by R is equal to E plus F. Can I call this as my ultimate formula? Can I call this as my ultimate formula? Yes or no, everyone? Can I call this as my ultimate formula? Alright, so this is your ultimate formula. But when can you use this formula? Only if your theta is not more than 6 degrees. Okay, if your theta is more than 6 degrees, you will find one previous year question of GATE in which theta is given to you as 33 degrees. In that case, you cannot use this formula, because if you find 1 minus EF, it will no more be almost equal to 1. Then you have to use this formula. Only if theta is greater than 6 degrees. Is it clear to all? Is it clear to all how to find super elevation? You have to take care what is the super elevation value, what is the theta value. You have to take care. Yes or no, everyone? Is it clear to all? And see, this is a very important session, guys. Very, very important session. So share the session as much as you can. Okay? It will definitely kickstart your GATE 2023 preparation. It will definitely kickstart your GATE 2023 preparation. Okay, yeah. V square upon GR. Very good. Very good. That means Abhishek is very attentive. Okay. Last two steps one more time. Which these two steps? See, your centrifugal force is mv square by r. Mass can be written as weight upon acceleration due to gravity. So P by W will be V square upon GR. That's what I've written. Very easy. Very easy. So subscribe to the channel, everyone. I'll be coming up more such interesting sessions which is going to help you kickstart your preparation. Okay. And you will be at a very good position, and you can make your subject improve even much better with this prior knowledge of such important topics. Okay, subscribe to the channel, like the session, and share as much as you can. It is really going to help kickstart your preparation, everyone. So moving on. All right, moving on. Next point, guys. Now this is your how to find super elevation, and this is your maximum super elevation. Remember this as well. I am going to come back to this also. So 2 points I have told you already, in which I am going to come back to. Okay. Now what is the equilibrium super elevation? Very interesting concept. Very, very interesting concept. Now suppose if you are running in a circular direction like this, and you are overturning in this direction, what is going to happen? Your one foot is going to lift up. See, when you are overturning like this, what is happening? Your one foot is lifting up and the other foot is taking all the weight. Yes or no? When you are overturning like this, your one foot is lifting up and the other foot is taking all the weight. In the previous case, in this particular case over here, okay, the reactions which you are going to get, the reaction RA, let us call this as RA and RB. In this case, tell me which of the two will be greater, RA or RB? Which of the two will be greater? Just tell me A or B. Just tell me A or B. Which of the two will be greater, RA or RB? Which of the two will be greater? No, Abhishek. About which point it is going to overturn, A or B? So if the vehicle has to overturn, it will overturn like this, right? The vehicle will overturn about this point, like this. And if it is going to overturn like this, this tire will lift up and all the weight will be taken by this tire. So obviously RB will be greater. Obviously RB will be greater. Now, equilibrium super elevation refers to the point at which RA becomes equal to RB. RA becomes equal to RB. So, what are the components that we have? P cos theta, W sin theta, P sin theta, and W cos theta, right? These are the components that you are having. Now, when will these two forces will be equal? When these two forces will equate itself. Okay, when this will become equal to this one, then there will be no frictional force required, and when there is no frictional force required, this force will be exactly split into these two equally. Okay, so P cos theta will be equal to W sin theta then P by W will be equal to sine theta divided by cos theta. That means equal to tan theta. So P by W, when it becomes equal to your super elevation, that means your P by W is equal to V square by GR. When it becomes equal to super elevation, that means your friction factor is 0. No friction is taking over here. There will be no friction over here. When these two will balance each other, there will be no friction at all. Okay, and you can find it by just taking a movement about this point. Okay, just take the movement about this point and you will find RA will become equal to RB. Okay, you can do this by yourself also. You just have to equate the movement at this particular point, or you take the movement about this particular point. So you can easily find out RA will become equal to RB. This is homework for you. You can verify this yourself. So equilibrium super elevation will become equal to V square upon GR. V square upon GR. Equilibrium elevation will become equal to V square upon GR. Now, one more note point I will try to give over here. See, in your numericals, you will be given velocity in kilometer per hour, right? And the radius will be given in meters. Why not substitute all the values over here to simplify our formula? So your super elevation will be equal to, now let us see, I will write kilometer per hour, velocity in kilometer per hour divided by 3.6. So this is in meter per second. Kilometer per hour divided by 3.6 is meter per second. You can cross verify. Whole square divided by G value is 9.81 into R. If you simplify this, you will get V square upon 127 R. You can simply remember this formula. You can straight away remember this formula. Okay? No, it is the equilibrium condition. No sliding will happen. It is the equilibrium condition. That is why it is called as the equilibrium super elevation. Okay? That is why it is called as the equilibrium super elevation. Clear, everyone? Alright. So, another very important concept that you have learned is E equilibrium is equal to V square upon GR, which is equal to V square upon 127 R. Okay. Over here, this is in meter per second and this is in kilometer per hour. I hope there is no doubt. Is it clear to everyone? Yes or no? Quickly comment in the chat section and let me know if all the concepts up to this point is clear to everyone. If there is no doubt to anyone, if there is any point you want me to repeat, just comment in the chat section and let me know. P will not be equal to 0. No, P is not 0. P will become equal to, P cos theta will become equal to W sin theta. P cos theta will become equal to W sin theta, and when this becomes equal to this, there is no more need of friction. When will friction develop, guys? When will friction develop? If someone slaps you, then only your cheeks will get red, right? That is because the heat is stored in this cheeks. Then only your cheeks are getting red. Now, if there is no unbalanced force over here, why will friction develop? Why will friction develop? Suppose if you are standing over here, no friction will be there below your feet. But if you want to move, if you want to push your feet in the backward direction, friction will act in the forward direction, and then only you will move forward. So when the friction is developing, only when there is an unbalanced force. If the two forces are getting balanced, no friction will develop. That is why friction factor of friction is 0. Is it clear to all? So I hope it is the concept is clear to everyone. Let us move on to the next type of problem. So just keep on writing, just keep on jotting down. All the problems are being solved. Very, very important concepts, and students tend to get confused. Stopped vehicle should not skid inward. Very, very important. And this is a very common case in India. Bullock carts are not allowed on where there is a lot of super elevation. On the road. Why? Let us understand. Now if this is stopped vehicle, so if it is a stopped vehicle, there will be no centrifugal force, right? So only weight will be acting in the downward direction. So one component of weight will be in this direction, W cos theta, and one component of the weight will be W sin theta. And in order to balance this W sin theta, your friction will act in the opposite direction like this. In order to balance this W sin theta, your friction will act in the opposite direction. F normal will be W cos theta. W cos theta. Okay. And in order to prevent the skidding of the vehicle which is stopped, your F W cos theta should be greater than equal to W sin theta, so that the stopped vehicle do not skid in the inward direction. Your friction should be greater. Yes or no? Your friction should be higher. So, right? So W and W cancels out. Over here, F should be greater than equal to sin theta upon cos theta, that is tan theta. So, in order to prevent skidding of the stopped vehicle, your friction should always be greater than equal to your superelevation. Remember this point also. 3 points I have told. First point was 3 points I have told you to remember. Can you tell me what are the points? First point, if you increase the radius, your centrifugal force will reduce, your overturning effect will reduce. Second point, maximum superelevation table, I have asked you to just keep that in mind. Third point, your friction should be greater than equal to E in order to prevent a slow moving vehicle or a stopped vehicle from sliding inward. These 3 points. Right? Let us move forward. All the dots are going to be connected. Design of superelevation, very important problem. Now look everyone. Let us connect the dots now. Now if at a road you are providing a superelevation, if it is a fast moving vehicle, okay, if you provide, let us say you have 2 things, right? Superelevation and friction. While designing, if you neglect superelevation, if you neglect friction and you increase superelevation, it is dangerous for slow moving vehicle because it may slide inwards, because F should be greater than equal to E. So you cannot neglect friction also. And if you keep superelevation low and you take full effect of friction, then the fast moving vehicle will overturn. Yes or no? So if you slow moving vehicle may slide due to this condition and fast moving vehicle may overturn due to this condition. So the IRC code has come up with the in-between solution. So he told that in order to calculate E, you take only 75% of the design speed and you neglect the coefficient of lateral friction. So E value is calculated, E plus F is equal to only 75% of the design speed divided by 127 R. So F is neglected and only 75% of the design speed is taken into consideration while calculating the superposition value. Is it clear to all? So if you simplify this, you will get V square upon 225 R. So you will use this formula to find out your superelevation value. Yes or no? Is it clear to everyone? Now, if the superelevation is less than or equal to E minimum. Now what is E minimum? E minimum is nothing but camber. What is camber? Camber is cross slope camber is, so if this is your road profile, we will provide some amount of camber. Some E minimum is provided, so that if there is any rainfall, it may just the rainfall is able to drain easily from the surface. Okay, it is not making any water pots. Okay, it is not making any, it is not stagnating on the road. Okay, it should drain to the sides of the road. So some minimum super elevation has to be provided. And if your E is coming out to be less than E minimum, then you will provide E is equal to E minimum. If E is less than equal to E minimum, then provide E minimum. How much is this camber value? How much is this camber value? This camber value depends upon the rainfall, if it is heavy rainfall or low rainfall, if it is a cement concrete pavement or high type bituminous pavement, then it is 2% and 1.7%. If it is a thin bituminous surface, 2.5 and 2%. Water-bound macadam and gravel pavement, 3% and 2.5%. Earthen roads, 4% and 3%. Very easy to remember. 1.7%, 2%, 2%, 2.5%, 2.5%, 3%, 3%, 4%. Very easy to remember. Okay, so this is the minimum super elevation that has to be provided in no case. Now, second is further. Okay, further. If E is greater than E minimum and less than E maximum, E maximum I have already told you, then you will take, then provide E. Provide E. And if E is greater than or equal to E max, then provide E equal to E max and check for lateral friction. So you have to now check for lateral friction, whether the friction is within the permissible limits or not. Is it exceeding the permissible limits or what? So moving on. So next step would be to check whether the friction is within the lateral friction is within the permissible limit. Now your formula will be E max plus F is equal to V square. Now full design speed will be taken into consideration, divided by 127 R. Now that formula will not be applicable. Now you will take full design speed, not 75% of the design speed. Now F will be equal to V square upon 127 R minus E max. Now if F is less than or equal to 0.15, then it is okay, no issue. And if F is greater than 0.15, then you have to restrict the speed to the vehicle. If you are reducing the speed, your centrifugal force is reducing. So now you have to check allowable speed. Check allowable speed, V allowable. So now you will come to the step number 3. Now you will provide E max also. Your friction factor value is also 0.15, and you will now calculate V allowable divided by 127 R. So now you will find out what is V allowable. So restrict speed to V allowable. So this is your design for super elevation. I hope it is clear to you all. Any doubt up to this point? And if you like the session, guys, do subscribe to the channel, everyone. Share the session as much as you can. Okay, this is going to really help you guys to kickstart your preparation for the GATE 2023. Yes, everyone. Any doubt? Wait, everyone, wait. Still 3 different types of questions are coming up. Very, very tricky questions. Students get too confused in those concepts, in those 3 questions. They do not understand the difference. What is the difference between these 3 concepts? I am going to tell you the difference. Let us continue, everyone. What is ruling minimum radius? what is the ruling minimum radius and what is the absolute minimum radius. Now first of all we need to understand what is ruling minimum speed and absolute minimum speed. Now these are the speed limits, maximum speed limits, okay. For a national or a state highway, the ruling speed, or also referred to as the design speed, ruling speed is 100 km per hour. All these values are in kilometer per hour. Ruling speed is 100 km per hour. But if in case you cannot provide all the specifications as per the national highway or the state highway, you can reduce the speed up to a least minimum of 80 km per hour for national highway or state highway. See, there may be some instances where you cannot provide the same width of the national highway, you have to reduce the width, okay. So for a national highway, you can only reduce up to 80 km per hour. Desired is 100, but absolute minimum is 80. Similarly, this is for plain terrain, for rolling terrain 80-65, so very easy to remember. So national highway, major district roads, other district roads and village roads, just you can write down afterwards. Very easy to remember. 100, 80, 80, 65, then 80, 65, 65, 50, 65, 50, 50, 40, 50, 40, 40, 30. Very easy to remember, very easy to remember. So you can remember all these values. Now you understand what is ruling speed and what is minimum speed. This is desirable, this is absolute minimum. In no case for this the speed limit should be less than this, okay. You have to design for this absolute minimum speed. If you are designing for anything less than this, then you cannot categorize. If you are designing your national highway for less than 80 km per hour, then it is not a national highway, okay. Then you have to reduce down the category. That is the meaning. So what is the minimum radius required for a vehicle to travel at the ruling speed? This is the minimum radius. Now if you increase the radius, your centrifugal force will decrease and your overturning will decrease, so it is good. But if in case you are asked what is the minimum radius you can provide, this is the minimum radius you can provide. If you provide more, that is your conservative approach, okay. You can provide as much as you can, okay. There is no issue in that. But what is the minimum radius that is required for a vehicle to drive at this ruling minimum speed? So it is equal to Emax, maximum super elevation, plus maximum your friction coefficient also, that is 0.15, okay. Friction coefficient will also be 0.15, that is F is equal to V ruling V square upon 127 R. So from here you can find out R ruling. From here you can find out R ruling. So this is the minimum radius which is required for a vehicle to drive at a ruling speed. And similarly absolute minimum will be Emax plus F equal to V minimum whole square divided by 127 R minimum. So this is the absolute minimum radius which is required for a vehicle to drive at minimum speed. Is it clear to all? Is it clear to all? You can provide more than this, no issue in that. If you have the liberty, provided, but this is the minimum that is required. You understand? Okay. This may be due to any physical circumstances. For example, there is a temple which is coming in the way. You cannot provide that radius. You have to reduce the radius. So this is absolute minimum. Write this. Okay. Last one is your radius, minimum radius beyond which no super elevation is required. Now suppose you have to provide a turn and there is no restriction over the radius. You can provide as much as radius as you can. So what is the minimum radius that you can provide so that no super elevation is required? So super elevation can be as less than how much? E minimum, which is equal to camber. So you are providing camber now. So E minimum. Now since you are designing, you will provide E minimum and you will only take 75% of the design speed because you are designing for minimum radius beyond which no super elevation is required. So V square upon 225 R camber. So R camber will come out to be equal to V square upon 225 E minimum. So this is the minimum radius. For example, you have to design a curve, and you have to provide a super elevation. This is the minimum radius you can provide, so that you do not have to provide any super elevation. You just provide the camber and you are good to go. Your design is complete. This is the radius you will provide. So I hope all the types of question is clear to you all from the top chapter from the topic of super elevation. Yes or no? A very important session, guys. Very important session, and I hope I have addressed all the doubts that you are having in your super elevation topic. All the types of question has been discussed. Any doubt to anyone? Any doubt to anyone? So tomorrow I'll be taking a session on traffic signs. Very important session again. You should all know what are the important traffic signs. I will be explaining all the traffic signs in detail. Okay, you can definitely watch the session. It is going to be a very informative session for you all. Okay, very informative sessions. If you ask yourself, how many traffic signs do you know? Do you know all of them? And then ask yourself, do you need to know all of them? If yes, you need to know, then come for the tomorrow session. I'll be taking a session on traffic signs at 8 p.m. tomorrow. Yes, very good, Yasveer. Very good question. What about transition curves? I am planning a session on that also. I will definitely take a session for that. Okay, just stay tuned, subscribe to the channel, and just stay tuned, click on the bell icon, and I will definitely be addressing that topic also. Okay, so thank you everyone. Take care. We will see you in the next session tomorrow at 8 p.m. And subscribe to the channel, everyone. Click on the like button and share the session as much as you can. Thank you everyone. Take care. Good night.